How many people have ever heard of chaos engineering before? All right, awesome. So no talk is complete about chaos engineering without talking about this little guy, Chaos Monkey. So Chaos Monkey was built in 2009 by a good friend of mine. His name is Greg Orzel. I actually went to high school with Greg. That's how I ended up at Netflix. And so if you don't know what Chaos Monkey does, Chaos Monkey looks for groups of servers and terminates one randomly every day. And so this is kind of the start, and it was a start of Chaos Monkey and the start of that kind of culture and notion and strategy of purposefully injecting failure into a system. And so fast forward a bit, this is a time, I like to say, this is Netflix's journey of chaos engineering. And I usually title this talk, the journey of chaos engineering begins with a single step. Okay? And in this, for Netflix, it started in 2009 with Chaos Monkey. I joined in 2010, and that was, I was quickly acquainted to the likes of Chaos Monkey. I was on call, I was carrying my pager, and I would just see my servers randomly go away. And so I got used to that very quickly. I got acquainted with the notion that things in the cloud can fail, that software fails, that everything fails. And so fast forward a bit, 2012, Netflix built Chaos Gorilla. Chaos Gorilla took out entire availability zones. Why? Because availability zones can fail. And then later on, I actually built a team called Chaos Engineering. I built a team that set out to double down on that strategy of failure injection. And we've delivered Chaos Kong to take out entire regions. Why? Because regions can fail. Anyone on call during the recent S3 fun? Yeah. And so the point that I like to make here is, and I put the years here, is that chaos is a journey of 1,000 miles. Chaos takes time. Resilience takes time. And so I did a few tech blogs about this at Netflix, and it got followed up by ReadWrite about how chaos engineering should be mandatory everywhere. And that actually got me to really reflect and stop. And while I loved working at Netflix, I loved working on an entertainment company, and I loved the team that I just built, it kind of made me stop to realize that perhaps chaos engineering, there were more applications that were more important than streaming TV shows and movies. And so that brought me to Twilio. So Twilio is a cloud communications platform that enables developers to build rich communications into their apps. And so what does that mean? Some of our customers, whether it's an Uber driver picking you up and calling you, whether it's an Airbnb confirming your reservation, or whether it's pager duty, waking you up at 3 a.m. in the morning. And so I joined Twilio, and I have this MO. It's chaos engineering, and I'm there, and I'm learning about the products. I'm learning about the customers. I'm learning about the use cases, and I'm strategizing on how do I get chaos engineering started here. What could we use chaos engineering for? And so the original title slide I had was actually a picture of a beach. And the quote is, "A journey of 1,000 miles begins with a single step." Now, when I talk about chaos engineering, I talk about Chaos Kong killing regions. Like, the picture of a beach in paradise is probably not the picture you have in your head. You probably have a picture in your head that probably looks a lot more like this. You're on this journey. There's a rickety bridge. You could fall to your doom. You're going through a mountain range with a lightning storm, right? And you're probably looking and thinking, really? Like, you really want to do this? You want to kill the servers and stuff? And so I will say chaos engineering is definitely a journey of 1,000 miles. And you don't have to get started with killing US East. We have a saying at Twilio that I really like. And that's saying, it's one of our leadership principles, and that is progress over perfection. It is prioritizing making progress on a problem over coming up with the perfect solution. And I really stopped to think about this. What does progress over perfection look like for chaos engineering? And so this talk, I designed this talk for the tired, for the pager fatigued. For anyone who's ever gone to a Netflix talk or read a Netflix blog post and gone, that's cool, but I could never ever do this. And so progress over perfection actually is present in many, many professions, not just our profession. So whether you're a pro athlete, whether you're a medical professional, or a professional musician, each of these has a long journey. You could each say that they have their own journey of 1,000 miles. And they also have a bunch of firsts, whether it's that first competition, whether it's that first patient, or that first performance. You see, it takes years to develop all the knowledge and skills, and it really takes practice. Knowledge is not a replacement for skills and practice. And so, to help me tell you this story about the journey that we've been on at Twilio, I'd like to invite up James Burns, who's a tech lead on my team at Twilio.
So when we originally started this, our journey into chaos engineering as a team started when Bruce came to me and asked if I wanted to be a master of disaster for a chaos game day. And I had the same question maybe you have, which is, what does that possibly mean? So he explained to me, a chaos game day is a controlled exercise where the team knows that there's going to be an incident. They're set up, they're following their standard incident procedures, and then the master of disaster causes the failure, usually in the stage environment. If you want to go big, you could do it in prod, but probably not starting off. And so when he told me this, I thought about all the different kinds of failures I'd seen. I thought about the craziest things, and I thought, how would I take that to the next level? So I was thinking, I'll be like this guy, and I'll be sitting across from the team. I'll be like, network partition, drop prime numbered packets, all kinds of crazy ideas. And so I talked to Bruce and asked him, what should we do? He's like, let's start simple. So that's what we did. SUDO HALT. Sit down across from the team, declare start of incident. I shut down a box. Should be easy, right? The team's sitting there and they're looking at their dashboards and their graphs and they're like, what did he do? What did he do? And they're not seeing that I shut down a box. They knew I'd done something, but they couldn't see it because of the way that things were built. And so what did I do? What do you think? I shut down another one. And another one, and another one, until there are no boxes left. And they're like, oh, boxes are shutting down. And so after that, we practiced the next skill that you need to have, which is not just incident response, but postmortems, and then using postmortems to drive improvements. So we sat down and we did a postmortem of an incident and stage. As part of that postmortem, we went through the steps of defining the timeline. Here's when James started shutting down boxes. And all the different steps of that, looked at how we could generate betterments out of that. And one of the major betterments out of that was that we needed to develop instrumentation that reflected the health of the system, not just certain subparts of the system, that you wouldn't see the impact until you were at 100% down. So got that done. A few weeks later, all the betterments were in code, were deployed, and we decided we were going to do another chaos game day. So same thing, I was sitting there trying to figure out all the crazy things I could do. And I decided, you know what, let's just start with SUDO HALT. And because of the changes that they'd made, because of the changes that they had in how they looked at the system, they immediately saw the issue, they were immediately able to respond, replace the capacity that had removed, and we declared the end of that incident. So went on to the next thing. Third-party APIs. So the system that we were building that was still pre-production had dependencies on a few different third-party APIs. So I was like, I wonder what will happen when those go down, because third-party APIs go down. That's what they do. And so I took an off-the-shelf traffic shaping solution, installed it on a box, and started dropping 30% of the packets to one of those critical APIs. And I had the same stats up, all our new fancy dashboards and graphs and everything. I was looking across from the team, and normally I try and like have this poker face so they can't see what's going on. I was so shocked. I'm like, that's not what I expected to see, because I couldn't see it. I knew I was creating a failure. I knew we'd build all these dashboards so that we could see failure, and it wasn't there. And so turned it up from 30% to 50%, 50% to 70%, 70% to 90%, eventually full failure. Oh, look, it's visible. We have a full failure of that API. We can see that it's impacting the system in the way that we expect it to see. And then of course, we declare end of incident. I roll back the changes, and we can go through the postmortem process. And out of that postmortem process, we said, hey, we should do more instrumentation. We should build graphs that show the performance of these third-party APIs. So let me talk to you really quick about numbers. So lots of people, when they're doing presentation, like to throw out big numbers. You have these numbers, and it's 2 a.m. in the morning. Do you think those numbers are going to help you? So once you've got past that, once you're like, OK, I need numbers, but I need them in a context, you end up with something like this, a line. And then you're looking at that line, you're like, hey, that line's pretty good. It showed me this incident, but it didn't show me this other one. So then you have a bunch of lines. Maybe you try a heat map. Maybe you try some stack bar graphs. Whatever it is. And part of the beauty of Datadog is it gives you all these different tools that allow you to build these highly customized visualizations for the different kinds of metrics. But part of that power is that you need to use it appropriately. You need to be able to find the appropriate way to visualize the problem that you have so that when you're sitting there at 2 a.m. in the morning and you're looking at all these different graphs, you actually can, you actually can come to a conclusion about what's going on. So what you need to ask yourself is these questions. What visualization will I need to see this kind of outage? And one of the easiest ways to do that is to cause the outage and see whether you would see it or not. That was one of the main lessons and skills that we developed as part of we did this chaos engineering exercise. Next one is, how do I validate my visualizations? And the same goes for alerting as well. How do I take this thing that I built? I built code into my, I built instrumentation in my code. I built instrumentation around third-party APIs, whatever it is. How do I validate it? And last, can I tell a story about my system using these dashboards? Can I say, I've got a failure, and I can go through and ask the particular questions to the dashboards that will give me the story of what's causing that failure, get me to root cause, and get me to mitigation to stop my customers' pain. So these are some of the things that we learned during our chaos game days. One of the first is you need instrumentation. If you don't have the data, you can't graph it, and you can't understand it. You need to make sure that you're instrumenting all the different places. One of the interesting developments that we saw was that our engineers started thinking about failure first. And they thought, you know what, I'm going to need a metric here because this is probably going to fail. And I'm going to transition that metric into a graph here, and then I'm going to validate that during a chaos game day. You want to understand the SLAs that you need from the APIs that you depend on, whether those are internal APIs or external APIs. And they're probably not going to be the same as the actual API provider. So being able to monitor the performance of the APIs you depend on, understand them, and then make decisions based on that. And that was this last thing, architectural change. So when we instrumented not the API that I had made fail, but some of the other APIs, we found that they weren't providing the performance that we thought they were going to. And so we ended up talking with a lot of different people in the organization, and we ended up getting to product manager, and they're like, yep, that's not what the API is meant to do. It's not going to have the SLA you want. You should probably use something else, which is actually a great answer, because then we aren't building a system that will fail. So we made a change. We started using a different API for that particular part of the system. And as a result of that, in the first 2 weeks that we rolled this out into production, we scaled 100x. with no problems because we were ready, because we had done the testing, because we had caused the failures. We understood how our systems were going to scale, and we understood how our dependencies would scale as well. And so since then, we've also gone 2x past that. So no problems, lots of confidence in the team, and the skills to understand when there are failures. And so we got all this done. Groups like, we're rock stars now, you know. So we decided to do another chaos game day. And same thing, sitting there. I'm like, oh, now I can't do sudo halt, probably not go work. And so what I did, and sat down, and Bruce was looking over my shoulder during this. I'm like, what if I turn down the quota on a dependency that I know is a secondary dependency of this other API over here? I bet that'll get them. I bet they won't be able to see it. So I did it. The alerts fired. The graphs changed. The engineer found it in 5 minutes, mitigated it immediately, knew exactly where to go. And that was it. But that's success. That's success that even trying the cleverest thing I could do, it just wasn't there. So I suggest you all try this. It's an easy process. And back to you, Bruce.
Thanks, James. So one of the things that James didn't tell you was a conversation I had with him. And I had a conversation recapping this kind of the journey of our chaos game days and kind of our sense of where the team was at and the skills that were being built. And James comes and turns to me and looks at me and he goes, it was really easy being master of disaster the first time, but it's actually gotten very hard to break the system in a way that the system won't be resilient to and that we don't have instrumentation. And I turned to him and I looked at him and I said, good, that's what we want. This is success. And so back to the professions. So whether it's your first competition, or your medical professional, even medical professionals call it a practice, right? Or your musician. It takes years and years to perfect these crafts, and it takes years and years to perfect our craft. Execution is not luck, it's skill. And so generally speaking, outages make engineers better. Outages help you understand how the system works or doesn't work. It helps you understand complexity. It helps you understand engineering. The difference is chaos lets you learn all that without affecting your customers. And so it actually helped, I noticed that it actually helped level up to the team's abilities and skills. This is Sneha. Sneha went to UMass. She interned at AWS on the EC2 team. And she was new grad talent on my team that just joined our team. And we saw her grow over these chaos game days tremendously. And so thanks to these game days, Sneha has become extremely efficient and proficient and confident in her on-call responsibilities. But more importantly than that, she keeps failure top of mind. And so when she's developing that new feature, when she's working on the system, she's actually thinking about what is the instrumentation that we need to add to this. She's thinking about designing the system for failure and resilience. How many of you guys are hiring? Anyone hiring in the room? Right. Okay, how many of you are hiring people out of college? Can you imagine how many outages it takes for an engineer to become proficient? Right? Everyone remembers their first outage. I remember my first outage. I remember the first time I carried the pager, right? And so this is a way to actually give your teams and your talent a way of leveling up, a way of experiencing failure without actually worrying about, killing the customer. And so, kind of a recap. So the thing that we realized in retrospect of this. Chaos helps your culture and your skills. So by experiencing this, you develop skills faster. It's a good accelerant. The first time we did this, the team was a little bit nervous. The team was like, oh, like, I don't know, like, I don't want people to see that I don't know how to do things. Like, they were really nervous and timid. By the end of that first one, the team came back to me and was like, hey, can we do this like every week? Because it makes us better. As a manager, when your team is asking you to do, like, it's like hygiene, right? It's hygiene or doing the dishes. When your team is asking you, can we do the dishes all the time? Like, yeah, of course. This is also about talent, so it's about developing your talent. Everyone has talent, everyone's hiring new people. So whether you're a senior engineer or you're a junior engineer, you need to learn about that system. The systems are complex in nature, the systems that you are coding for. It takes a long time to learn about these things. Chaos gives you that accelerant. It accelerates your learning curve for any system. And ultimately, it gives you resilience because it keeps failure top of mind. Because it's top of mind, because you also understand the system better, how it fails, you're proactive in thinking about the resilience of the system. And so then the system doesn't actually go down very often because you're thinking about that up front and you're validating that your code is or does not work in the face of failure. And so the net result is you actually need to continue doing game days because the system's not going down very often. And so this is about retaining and maintaining your skills on call to know how to answer that pager at 3 a.m. in the morning. And so the other journey I've been on is with Twilio. And so while Twilio powers the Ubers and the Airbnbs of the world, they also power a few other companies like these. The Polaris project built an app called Be Free to rescue people from human trafficking. Trek Medics International built a community-driven emergency medical response for countries that don't have 911 infrastructure. And Crisis Text Line answers texts for people reaching out in crisis. And to quote CEO and founder Nancy Lublin, Crisis Text Line dispatches active rescue 8 times a day. Lives are changed and lives are saved thanks to companies like these. And so in retrospect, for myself, I've kind of realized that this is why we have to do chaos. This is why chaos is important for Twilio to do. So in closing, when you wish upon a blue moon, may your CPUs overheat, may your hard drives crash, may your humans make mistakes, and of course, may your networks partition, partial and full. Thank you.